Alright, good afternoon. Last time we learned 4 operations among functions: addition, subtraction, multiplication, and division. Last thing we did was this: we divided 2 functions. Once after we evaluated each function at 7. So if you see a number here, you evaluate that number into the functions, and then you divide the resulting numbers. Today we're going to do one last question about multiplication, and I see that multiplication right here. It's between P and Q only, so we won't be needing this. Not only perform the multiplication, this question has a second part. They want us to find out the domain of the resulting function. The result will have, and it will be a new function and a new domain. Get it? Okay? There are 2 ways of doing that. You either get domain of P and Q separately and then overlap them, intersect them, and find out that way, or get the equation of the product and determine the domain right from that equation. I would prefer the second way, but if you have no clue how to get the result, but you are just wondering the domain of the resulting function, find domain of each function and overlap it. Okay? Alright, let's first multiply P and Q. Alright, P dot Qx means you take P of x, you take Q of x, and simply multiply them. Just take that P of x, whatever is given, and Q, whatever expression it reads there, put them back into place here, and do that multiplication, and there we go. That's it. This is the product. We found this. Alright, are we required to distribute this and multiply completely through? No. Not necessary unless it's simplifying. I don't see, once I pass this into both spots, there is no simplification at all. So I'm not going to completely multiply it. Okay? How about the domain though? Domain of this resulting function. Are we allowed to submit any kind of numbers here and get a new number out of this expression? Or are there some bad values that can break down some part of this expression so you can't compute it? Remember when we were finding domain back in the old sections, I asked you to beware of 2 types of functions. Fractions, like 1 over x, because if you choose x to be 0, then this is 0, or x minus 3 has a bad value at 3. 1 over 3 minus 3 is undefined. And the second type of functions I ask you to watch for is, do you know what kind of functions you must be watching for? Radicals, or square roots, more specifically. Radicals with even indices. Even index means this index in the radical should be either 2, 4, 6, 8. And most widely used ones are square root. Square root of x, for example. When I enter negative numbers in x, I can't compute them, they break down. In this question, are there any square roots or fractions? If so, find the values that makes them sick, or find the safe values and list them in domain.
I have to less than 4.
Anything less than 4? Or more than 4? Less than 4. So you're saying 1 is bad? 1 is less than
No,
4.
like, the good ones are less than.
Oh, good ones are less than 4. Okay, then you're saying 3.5 is good. No, it's bad. So you need to back up a little bit. 3.5 is bad, 3.4 is bad, 3.1 is bad.
Anything greater than 3.
Anything greater than 3 is bad. But we want the good list, right? So good list is anything less than 3. But how can we really catch everything securely? Just whatever you're thinking, say it in words, in actual expressions. We want inside to be greater or equal 0. I want inside either 0 or more. 0 is good, okay? 0 is good. And so for this thing. I will subtract 3. And divide both sides by -1. Once I do that, don't forget to flip the sign, because dividing by a negative is a game changer. This cancels, by the way. X is less than 3. So we just verified what we already deducted here. Everything less than or equal to 3, 3 is good, or anything less, makes this guy healthy. You can compute it like plug in 2, 3 minus 2 is 1, root 1 is good. Alright, so we covered this angle. I'm okay with this. And I have to keep taking everything less than 3. How about this side? Is there any value that can make this function sick, that part of the function sick? X squared minus 5x? Any number we should be avoiding to use in this x? Is it good? Everything good? You sure? How about 0? Is 0 good? Yeah, 0 times 5, 0 squared is computable. Nothing wrong, right? Correct? So nothing bad can happen on this one, because this is a polynomial. Polynomials always welcome every kind of number. Any kind of number welcome, but not radicals. No fractions. So we are actually done here. You need to just write all numbers less than 3 in interval notation, and I don't know how to do that. How do I write all numbers less than 3 in interval? Yeah. We go up to 3, but we need to start earlier, all negative numbers up to 3. And we like to have 3 in there, so we put a bracket on that side. Okay? We're done with this function. Any questions? Alright, let's take a look. X squared minus, not there, go down, yep. Minus 5x times square root is made this way, 3 minus x, check. Good, interval notation, negative infinity to 3 brackets, check. We're good. Alright, we're done with the first half. 4 operations over. The 5th operation among functions is composition. And this can be a little challenging for if you're seeing this the first time. What is this called again? Compose functions. Oh, you have 2 functions. Alright, visualize functions with a real life example, such as some people think functions like machines. They take some product in from one side and give a new product outside. Like a machine that produces something. Give me a machine you use every day.
Microwave?
What?
Microwave?
Microwave?
Yes.
Doesn't really transform much. It just heats up. Some output is not quite different. So such as you put wood in here and a machine that turns it into a spoon. Have you ever seen a wood spoon? No? You never used one? Come on, yeah, wood spoon, you use it, okay. So you don't scratch your expensive pens, I mean the one you use in soup making, etc. Okay, anyways, you put wood, spoon, and then you take this spoon and as you see that, I didn't like the color of the spoon, you put it into another machine, it makes it into a green spoon. Right? So this is a painting machine. Or you want to heat the spoon in a microwave. Okay, so a heated spoon, hot spoon. Anyways, okay. So, or you may think functions like buses. Here, passenger 1 rides on this bus and gets out of the bus in 3rd Street. 1 goes to 3. And then on 3rd Street, he takes another bus and goes to 10th Street. Maybe buses are more suitable. So you take 2 buses. That's what composition means. You use the first bus, get out of it, immediately take the next one. So it's a chain reaction between 2 functions. And that notation is described, this means composition. So how do I know the operation among the two functions? It's not plus, it's not minus, it's not dot, it's a circle. That means composition. So whenever I see that, order matters though, the passenger, whoever this passenger is, gets into first bus is G, not F. You read from right to left. So you need to send this passenger to bus 1. And then wherever bus 1 takes him to, he gets out of it and rides onto the next bus called F. Okay? So is it clear what the composition means? Basically, in rough idea, you use a number in the first function expression and then get a new number and use it in the next one. It's a lot easier if I do it on an example to understand. By the way, there are 2 notations for it. Some exercises use this one, some uses this one. They are equivalent. So again, what does this mean? It means it's under the value of G. It uses G bus first, and then you compute that and use the result into F bus. And in this question, it's using the second notation. So what I need to do is, I need to use 3 in F first and compute it under F. So cover those items you don't need. We don't need this yet. I don't need this yet. All I see is 3 is taking F bus. So I need to send 3 into the F bus and compute it. How? This is how. Just substitute. Substitute and compute. What is the result? 3 cubed is 20 what? 27 plus 9 times 3 is, what a coincidence. It's not 93. It's 9 times 3 is 27 as well. So we now know where F takes passenger 3. F took this passenger 3 to where? 54. So what you have here is F and 3 gone, and it turned into 54. You see? Can you follow me? So what you have in this question now is G is still there. G survives. We haven't used G anyway. Only we did the mid part, center part. 3 went to 54 with the F bus, and 3 transformed into 54. Like you had 3 woods, you made 54 spoons out of them. You put 3 plank of wood into the machine. Machine gave you 54 spoons. What am I gonna do with these 54 spoons now? I'm gonna send those spoons to oven to heat them up with microwave, right? So this is your second machine or second bus. It's gonna take 54 spoons and turn into something else. So for this, you need to uncover that function and see its equation and cover everything else. You don't need this. You never use this. This is the turn, G's turn now. G will consume 54. Let's do it. Send 54 spoons to G and see what this becomes. It becomes 3 times 54. What is it? 162. But what is 162 squared? Square root. Yeah, it's not a whole number. We still need to reduce this. Instead of multiplying here, alright, you multiply on top of your head and get 162, and can you take square root of 162? No, then back up. Back up, because this is not a whole number. So what do? Instead of multiplying, I will further break down these numbers. Break 54 into 3 times 18. And then break 18 into another 3, and 2, 9 times 2. Right? 18 is 9 times 2. And we have how many 3's here? And 2 by 2, I can take them out because this is 3 squared. That's 3 squared. So they can get out of this prison by paying a fee. What fee? The square root and square cancels each other. Answer is double 3 comes out, but that poor 2 doesn't have enough fee, still locked inside prison. So the answer is 9, because that's 9, root 2, most simplified version. Okay? Let's try this. Again, you need to reduce to the most simplest case. Did I solve the right? Oh. By the way, I solved, my question had 3, this question had 5. So I can't test my answer. This is 5. But can we rework this? Let's work with 5 again. It's just like a new problem. The real question has 5 in it. Alright, send 5 into F bus. What is the answer? 5 cubed, 125, 45, 125, 45 more, 170, right? Okay? Now send, this is 170. You guys have G of 170. You got 170 spoons. We need to color them in G machine. So you just need to send all those spoons to here. Immediately to this one. Okay? And you get 3 times 170, which is 510. Alright, how do you factor this now? I'll try to break 510 into 51 and 10. This is 2 and 5. This is 3 and 17. Oh my god. No matching numbers. All distinct. I was hoping to get a pair of the same numbers so I can break prison, but never happened. So don't break this because there is no repeating factor. All distinct. So This is our final result. Unless I haven't messed up somewhere. Any questions? Any mistakes? Let's test. Oh my god. Yeah. I made a mistake again. It's not G. It's H. I mean, it's not a mistake. It's just this is H. So I put the 170 into the wrong machine. 170 should go to H because this is H. So 170 spoons not going to here, there. That makes sense. Now if I put 170 here, that is 4,200, no, 1,195. Of course not. 600 plus 420, 10,020, 10,050, 1,015. Hopefully this is gonna work. Wow, we solved 3 questions. I hope I got the right answer. Thank you. Well, did you get it there? That's what matters. Okay, whatever number you see first, you send it to the first letter next to it. I did, and computed a number. And this number goes to the second letter. Here, you just substitute and compute. That's the short story. You send the number one by one to the previous letter, and it changes at every step. Okay, don't worry, we'll do another one. How about this? Let me first double check. We're doing 8. Do you want to do another one before 8? With numbers? Here is the difference. This is using a number 12, a real number. Here it's just saying do this with axis. How many people wants to see number 7? Number 7? You can do this? Okay, then I'm going to 8. Again, the difference is we're working with axis instead of number. Look, it says send an anonymous passenger. We don't know what this number is. It remains X. Here we knew that number. It was 5 given. So how do we work with variable axis? Let me copy this. But I'm going to copy this in the second format. Instead of Q circle M, I will do this. Q M O M O X. This is the same as Q circle X. Q circle MX, okay? This is given, I just changed it into the second way. Look, just follow the same recipe. Just like 5 earlier, took this M bus. Now let X take M bus. Let X take M bus and tell me what happens to X. If X takes M bus, it turns into this mess. X is gone and it's converted into this. So what I'm gonna do is, in other words, don't you see here M of X, entire M of X, and here M of X? So you just find M of X is this thing and put it back in here. Okay? So we have this as Q of this guy coming in here, square root X plus 3. Does it make sense? Look, I read M of X inside this parentheses. I find what is M of X up in this line, copy it and put it back. Here is coming next. Alright, forget what you have here. Forget it. And imagine here a giant X. A giant X. Right? Forget the square root. Instead you have an X. What would be your answer? I'm asking you, what is Q of X? What is Q of X? It's not here, this is M of X. What is Q of X? Q takes X into this, turns it into this formula, right? If X rides on Q, it goes to 1 over X minus 5. So I would put here 1 over that giant X and minus 5. But we don't have a giant X there. What do we have? Then take it back. Take what you made back. Instead of this X, I have underneath it square root X plus 3. There you go. That's it. Alright, here is the short story. Step 1, copy the formula of the middle function. I just did. This is just copying. Step 2, copy the formula of the second function. However, remove all x's out, take all x's out. Instead, put back whatever you have here. Whatever you have there, put it back. Okay? Can you digest this? Process this in your mind? Copying, first step is copy. And then copy the second formula as well, but instead of x's, put it back what you see near. Alright, that was the easy part. I have found this, but the question I bet is not over. Create a fraction. The top was 1, bottom was starting with square root x plus 3 and minus 5. Check. Here is the trouble point. Find the domain of the new function you just obtained. You found a new function, you created one. Tell me, is there any values making this function sick? Take them away out of the good number list or domain list. So what makes this function sick?
Everything less than -4.
Alright, I see radical. As Andrew said, we need to watch for negative numbers under radical. So we must exclude anything less than minus 3 because it's going to make this negative. So we must take first, we must have x values greater than minus 3, greater or equal. I just set this into more than 0. Actually, how did I get this? You don't have to guess. Algebra, you can find it by algebra. Just set the inside. Set the inside more than 0 and solve. When I solve it, I got this result. So this is my initial response to this question. I must take all numbers more than minus 3 to keep this radical happy. Is this the only thing we need to keep happy here? We also have, look at the big picture. We have, what do we have here? A fraction. We need to keep the denominator of the fraction happy. So how do I make the denominator of the denominator happy? This is the denominator, right? This thing should never be 0. we must have this more than -3, this non-zero. Yeah, we need to get this simplified. I add 5 to both sides. This means I must not have, cancel. I must not have the square root, never should be 5. That's not it. I'm squaring both sides next. We need to isolate x. That's what I'm doing. We need to isolate x. Cancel. No, cancel. X plus 3 is not be 25. And finally, yes, we mustn't have x as 22. No. If x is in here, we must take it away. So let me visualize the result. You said initially everybody more than -3 is fine. Here is -3. You said I'm okay with this entire interval. This was your response earlier here. But now I'm saying that, no guys, you shouldn't be taking 22. So what am I gonna do? I take my eraser and wherever that 22 is, I'm gonna hunt for it and make a hole there. So your interval has a gap. You cannot write it as a single interval. So how can you write it now? Union. We need to make this piece first. That's -3 to 22. Parentheses. Unite, skip 22, and go to infinity. This is it. Make sense? Are we good? Remind me to put this question in exam. It's a good one, right? I hope we got it right. Ooh, yeah. Any questions? Alright, going for the last question, looks like graph questions easy. But this has many parts. How many? 7 parts. This is a really comprehensive, very instructive question. I like it much. So let's take a look. Alright. There is a graph of 2 functions here. 2 functions. Do you see them? 2 colors, 2 functions. Good. Blue and red. Red is P, blue is M. So what are we going to do with it? You are going to add these 2 graphs and evaluate it at 2. Add these 2 functions and evaluate at 2. But they didn't give me the equations. I wish that I was given an equation here for M and P. I could just add them and evaluate them at 2 and we could be done in 30 seconds. But instead they have provided me with graphs. What shall we do? I need ideas.
Figure out the equations for each of the lines.
I don't think we can figure out these equations because it's a broken line, like one equation here, that's y equals 4. There is another equation, another equation, another equation. 1, 2, 4 equations for red. 1, 2, 3 equations for blue. Let's not do that. And it's doable though, I agree. You can get equations of each part with slope and 1 point on it. Yeah, you can get those equations, but you don't really need them. I mean, if you know a short way, other way. Okay, let me help you with this. Sum of two functions at the value means you find each function at that specific value and sum it. In other words, find where 2 goes with M bus, wherever he goes, 2 goes somewhere with M bus. That same 2 goes somewhere with P bus. Find their destinations and add them. Where's your passenger 2 waiting? Here's your 2, right? 2, look. Let's send them into the M bus. Where are you, M? Blue one. He's walking to M bus and hitting the M bus, riding it. This is the point. Where is he going with this bus? Where? Yeah? Cody? 3. Yeah. It's the y coordinate of this stuff. It's 3. 2 goes to 3. There you go. Let passenger 2 go to the P bus now. Where are you? P is the red one. So this 2 is now riding red bus and see where he goes. When you hit it, there is a point formed and you just need to read its y coordinate, which is what? 1. What is 3 plus 1? There you go. Not bad, huh? Okay, that was just the beginning though. Next time, what are we doing? P minus N at 3. P minus M at 3. That means you first compute 3 under P. Order matters. You first take it at P, and then you take it at M, and the results must be subtracted. Alright, where does 3 go under P bus? This time your passenger changed, remember? So here is my 3, and I'm riding the P bus. No, this is not P, this is M. Wrong. Oh my God, I'm already on the bus here. I don't have to go meet the bus. It's already, I'm on it. So I get on the bus and get out immediately. It's not moving me anywhere. At least here you moved up and then went somewhere. I'm already on it. So what is this value? This is 3 what? So which place did you go? 0. The bus didn't you take anywhere, it's just you dropped at the same location. That's P. How about M? Next time to go to M bus, you need to walk and ride the bus and watch where you're going. Where are we going? What's this value? 2. 0 take away 2, minus 2. Agree? Alright, M over P3. That means you need to compute 3 under M You need to compute 3 under P. Find them out, divide. What is M of 3? Oh, we already did it. Haven't we? You don't need to reinvent the wheel, it's here. Just read one line above. What is M of 3? 2. What is P of 3?
2.
Okay, here is the $1 million question. What is 2 of 0? 2 over 0? Undefined. Do you agree? We can't divide a number into 0 pieces. It's undefined. So how do we type this in? Oh, there's a button just for that. MP1 multiplied that means find M01, find P01, multiply the results. Alright, where are we? 1 here. Under P it goes to 2. Under M it goes to 4. 4, 2, 8. Agreed? Did I get it right? Here's the passenger 1. Go hit the P bus. I did. I'm pointing 2. Go hit the M bus. It's going 4. 2 and 4 multiplies to 8. Make sense? PM0 multiplication, right? Multiply P and M once you evaluate 0 in them, right? Agree? That's not multiplication. This is composition. Now this was gonna give you a hard time, I believe. POM. What was it? What was the number? 3? 0. Okay. So this means again, P outside, M is in the belly, 0 is first visiting M. That's what it means. 0 is taking the M machine or M bus and going somewhere. So really take 0, let him travel with this bus M and see where he goes. Alright, let's do it. This is too messy. Let's clean it up first. Find passenger 0 first. Where is he waiting for us? Here is passenger 0. He is going which bus? M bus. So you need to hit the M bus and make a dot there once you hit it. There you go. Wherever you make that dot, read its y coordinate. What's the y coordinate of this point? X is 0, y is what? 4. That means my passenger 0, once it takes the M bus, it goes to destination 4. This is now turned into 4. The wood 0 turned into 4 spoons. Now let's put these 4 spoons into painting machine. See what they turn into. 4 is going to P bus now. Find, again, we are done with 0. 0 is history. It was wood, it turned into spoon. So you need to use 4 in P bus. So find 4. Here is 4. Send it to which machine? P. So I go up and hit it and read its y value. Agree? You don't agree? Why?
It's the wrong one.
It's the wrong color. P is not this guy, it's the red one. Okay? I go down, no problem. I I just took the wrong bus, sorry, but I come down and try to get into this bus. Can you step on the bus? Can you meet with the bus? No, the bus is almost in the bus station, but they're not going in. Bus is broken. It stops an inch away from my bus stop. So how am I gonna get in this bus and go somewhere? So what's the result? What is the result? 4 can't go into P, then you're stalled. You can't find this out. Okay? So we are going with undefined on this choice. Okay? So 0 didn't go anywhere with these two buses. He's in the midway stuck. How about -2? Are you -2? Yeah. Let -2 right in these buses. In mixed order though. This time P is first, M is next. First P taking in -2. That means M is later. -2 is going into P bus first. Alright, send our guy -2 into P bus, please. Where is -2? It's here, right? P, where are you? There you are. Read the y coordinate, please. Which is 4 again. Our famous 4. This time taking M bus again. Same 4. We are at the same stage again, but not the same fate. This time you're not going down taking P, you're going up, traveling with M to where? 1. Okay? Any questions? One last question. MP1 -1? No, PM -1. Order matters. You can't flip the order. P M -1 is taking M bus first, later P bus. So let's see where -1 goes with M. -1. Find -1 first. -1 right here. Which bus are we sending him to? M. Did I get to M? Which value is it pointing out? Again 4. We keep getting 4. Okay. What is P4? We can cheat now. It's undefined. We found it earlier. P4 was undefined. Alright, this finishes up the question. Any issues here? And the section is over as well. Actually, the chapter is over. You won't get to see this anymore. The next time we're starting polynomials. Chapter 3.1 on Friday. Okay? Please sign up if you haven't done so.